Rule 8-400 of the Canadian Electrical Code, CEC, CSHA, 22, Satu, titled Branch Circuits and Feeders Supplying Automobile Heater Receptacles, or Vehicle Heater Receptacles for Vehicles Powered by Flammable or Combustible Fuels, provides rules for installing, protecting, and calculating loads for outdoor heater receptacles, for example, block heaters, engine warmers in parking lots, car dealerships, apartment visitor parking, etc. The rule includes two main tables in recent editions like 2021 and 2024. Adopted in Ontario's OESC that apply demand factors to determine the total calculated load for service or feeder sizing. These tables recognize diversity. Not all receptacles will be used simultaneously at full load, especially in large installations. Key subrules overview before the tables. Rule 8-401 Branch circuit requirements. 1 dedicated branch circuit per duplex receptacle, or per 2 single receptacles. Overcurrent protection, max 20 ascens, 2 μe, desoi 2 sei, was 15A prior? Rule 8-402, connected load per circuit, based on the branch circuit overcurrent device rating. For example, 28 times 120 V equals 2400 VA per duplex. Rule 8-403 and 4 distinguishes between controlled, restricted, for example, timer controlled, key switch, or energy-managed systems limiting simultaneous use, and uncontrolled, unrestricted full availability. No limits on simultaneous plugging in. The two tables are used based on whether the installation is controlled, restricted, or uncontrolled. The demand load calculated from these tables is added separately to the building's other loads, for example. From Rules 8-200 to 8-210, do not apply additional dwelling demand factors like the 75% in 8-200 to 3D. To the heater portion, as diversity is already built into Rule 8-400. The two tables in Rule 8-400. Rule 8-400 contains two demand factor tables, exact column. Row values may vary slightly by addition, but the structure is consistent. 1. Table for controlled or restricted loading, for example, installations with timers, automatic controls, or energy management systems that prevent excessive simultaneous use. Higher diversity is recognized because controls limit peak demand, for example, only a percentage can be on at once. Demand factors are lower, more aggressive reduction for larger numbers of receptacles. Example structure, approximate from common editions, videos, explanations, number of receptacles or circuits. Gives demand factor, percent applied to connected load. Often starts at 100% for the first few, then drops, for example, 80%, 60%, 50%, etc., for higher quantities. Used when the system is designed to restrict loading common in multi-unit residential visitor parking or managed lots. 2. Table for uncontrolled or unrestricted loading, no timers. No restrictions, anyone can plug in anytime. Lower diversity assumed, as peak winter mornings could see high simultaneous use. Demand factors are higher, less reduction than the controlled table. Example, structure approximate. For small numbers, 100% demand. For larger numbers, for example, 20 plus, still relatively high percent, often 75 to 100% overall, depending on exact table rows. This is the table that applies to your previous example of a parking lot with 50 uncontrolled duplex receptacles. Demand is not as heavily reduced. Practical application, calculate connected load first. Number of duplex receptacles, times rating of branch circuit, for example, 52,400 VA equals 120,000 VA. Select the appropriate table based on control type, uncontrolled for your scenario. Apply the demand factors from the rows columns to get the total demand load for feeder service sizing. Add this to the building's other calculated loads, lighting, receptacles, HVAC, etc. If the parking lot is fully occupied under normal usage per se rule notes. Some authorities require closer to 100% demand for safety. Note, exact percentage values and row breakpoints, for example, for 1 to 10, 11 to 20. 21 to 50 receptacles are in the tables of the adopted edition 2024 CEC OESC in Ontario. They are not reproduced verbatim here due to copyright, but videos and guides, for example. Red Seal prep materials often show them as stepped reductions similar to other CEC demand tables, like Table 14 or 62. For precise numbers, consult the current CEC handbook or OESC directly. In Ontario, Vaughan projects, uncontrolled parking lot heater receptacles often result in higher demand loads than controlled ones. Always coordinate with the Electrical Safety Authority, ESA, inspector or engineer for the specific installation. This rule ensures feeders aren't undersized for cold weather peaks while allowing realistic diversity.